Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good day to everyone. So today I would like to continue our lecture regarding on the example 1, which we have stopped. Okay, we haven't discussed from our previous class, all right, regarding on example 1, which is for the common ammeter voltage divider configurations. All right, so if we look at these questions, all right, so the question asks for us to determine the value of input and output impedance, the AVOC. So when we said about AVOC, between the input and the output, all right, voltage gain AV, and then AVS, which is the gain at the source, yeah, AVS, okay, gain for the voltage source for the amplifier circuit below, which given the value of IC, which is 2.37 milliampere. So in this example, you don't have to calculate any more, okay, the value of IC current, all right, which has been given, all right, in the questions, and the VA also has been given to us, all right. So let's say the questions not given or not provide the value of IC. Okay, if let's say the value of IC is not provided, so what you can do is you can determine this using the DC analysis. Okay, so how we want to determine using the IC analysis from this circuit, which is you have to remove or make this as an open circuit. Okay, this will become open circuit. There gonna be no capacitor at C1, no capacitance C2, and no capacitance C3. Okay, so it will leave only this part. Okay, it will leave only this part, and your V out will be here. Okay, here is your V out. Here is your V out. So in that case, okay, in that case you can, for this, yeah, the DC analysis, just a little bit recap, so you can redraw the structure. So it's gonna be here your VCC, okay, and then your R1, and then your R2. Okay, I need to erase this here. Okay, okay, then you're gonna have R2, and then we're gonna have, okay, RE. This is your RE, all right, and then we're gonna have this is the RC, okay, and another VCC. So this is another VCC for this part. Okay, and this is it, all right. Okay, so from here, R1 and R2 we can simplify to become R Thevenin, okay, which is R1 is parallel with R2. Okay, so you can calculate. So R1 parallel with R2, it will be 8.2K, okay, 1.5K over 8.2K plus 1.5K, right? So you will get the value of R1 parallel with R2, we're going to be 1268.04 ohm, okay. And then from here, okay, instead of VCC, we can use, right, we need to find the V Thevenin, okay, remember, because this is the voltage divider configurations, all right. So for the V Thevenin, all right, it will gonna be R2 over R1 plus R2, and the value of VCC. So in this case, you will get 1.5K over 1.5K plus 8.2K, 8.2K, yeah, and then 20, so you will get the value is 3.093. Okay, 3.093. So this is the value of voltage, and we can redraw the structure to be based on this. Your structure will gonna be, here will be your V Thevenin, okay, and then here will be your R1 parallel with R2 value. Okay, and then I need to have my eraser again to erase this. Okay, alright, and then your RE here, this is your RE, and then this will gonna be your RC, and this will gonna be your VCC, right? Okay, so it's gonna be much simpler, right? And then you can perform the KVL to find the IB. Okay, and then here is the IC. Okay, so you can perform the KVL. Alright, so the KVL for the input loop here, you will get negative 3.093 plus IB, and then the value of R1, R2, 1268.04 plus IB, okay, the current that flow here, which is 121, okay, IB, so here is IE, right? Current that flow here is IE. The beta is already given to us. Okay, IE IE is equals to beta plus 1 IB, right? So gonna be 121, okay, 121 IB, okay, 121 IB, the current that is over here. Alright, multiply with the value of RE is 1 kilo ohm, plus I forgot about the VBE here, so plus 0.7, so you will get equals to 0. So from here you can find your value of IB. So you will get, you can calculate the value of IB, you will get 19.75 microampere. Okay, so once you got your IB, you can determine the value of IC, because IC is equals to beta IB. So you will get your IC is equals to 20 multiply 120, okay, 120 multiply with 19.57 micro, so you will get 2.35 milliampere. So this is the value of IB, IC, if it is not provided. But usually in these questions it will provide to you, but if in case it will not be provided, then you have to calculate using the DC analysis, which I have performed as I shown to you guys here. Alright, okay, so now, okay, so based on this information, okay, based on this information, what we can do to solve, right? What we can do to solve. Alright. Okay, so the input impedance, how to find the input impedance? Okay, so input impedance, so it is at this particular part. Okay, so this is your input impedance, right? Okay, so input impedance is given as, of course, we have R1, R2, okay, R1 and R2, and we need to consider this R pi, okay, because your R pi is provided. So R1, R2, and R pi. Alright, so before we want to solve this, what you have to do, you need to draw the equivalent circuit first. So the equivalent circuit, so we have the VS, alright, we have VS here, so here is your VS, RS, so here is your RS. So in this low frequency, what will happen to your capacitor will gonna be short circuit, right? So it will gonna be straight line. Here we're gonna be a straight line because it is a short circuit. And then we're gonna have R1 and R2, which is parallel, so that's why it is a parallel here, R1 and R2. And then what else do we have? We have of course we're gonna have, it goes into the transistor here, which is, this is your base, this is your emitter, and this is your here is your collector. Okay, here there is your collector. Right, so at this part, from the base to emitter, here, what we're gonna have is we're going to have R pi and V pi. Okay, so we have discussed this on a previous class. I hope you still remember. And then what else do we have here? At the emitter, we're going to have Re and this capacitor. But then what will happen in the capacitor for the low frequency? It will become short circuit, right? So here we're going to be short circuit. So since that there's no resistance here, your current will avoid to flow at Re. So instead it will directly goes to this area. So that's why in your emitter side here there's no resistance, yeah, so it's gonna be directly goes to ground. All right, and then what will happens between the collector and the emitter? So between the collector and emitter here, we're gonna have GMV pi. Okay, we're gonna have GMV pi, and we're gonna have R naught, because they didn't mention in the questions earlier the R naught is equals to 0. So, R naught is equals to infinity, so we have to consider our R naught. So R naught have to be considered. Then we're going to have our collector junction here. Okay, so this is your collector junction. So this is your collector junction for the R pi model. Okay, and then what we're going to have? We're going to have at the collector, we're going to have RC. So here is your RC. And then what else do we have? Your VCC will become ground, right? So they're going to be no VCC, it will become ground. And then what we're going to have, your C2 will become short circuit as well. Okay, this will become short circuit as well. So it will straight away go to your RL. Okay, it will straight away go to your RL. So we have RL, and this is your V out. And then we have to look, usually in the questions they will have allocations of input impedance and output impedance. So if you can see here, your input impedance is between the RS and the base. Okay, the one R1 and R2, it is before the R1 and R2 parallel circuit, parallel resistance here. So it must be before R1 and R2 and between them, yeah, between RS and parallel of R1 and R2. So in your equivalent circuit, your input impedance should be located at this part. All right, so you have to draw as well the input impedance where it is located. And how about your output impedance? Your output impedance, it is right before your load resistor. So it must be before your load resistor, and it is after the RC, after the collector resistance. So this is where your output impedance located at. All right. Okay, so in this case, if we want to find the input impedance, so this is our input impedance. So our input impedance will be counted as R1, R2. Okay, RS will not be counted. Okay, because RS is before the input impedance. Okay, right. So this is your input impedance. RS is behind of the input impedance, so it is not counted. Okay, so the one that is counted is R1, R2 and R pi. So R1, R2 is parallel, and it is also parallel with R pi. So R pi can be calculated. Okay, R pi is not given. Okay, of course R pi is not given. So in this case, we need to calculate the value of R pi. So what is the value of R pi? Okay, so the value of R pi is, remember, okay, R pi is equals to beta over GM. Okay, then what is our GM? GM also is not mentioned in the questions. They only mention that IC is equals to the value of 2.37 milliampere, and VA is equals to 200 volts. This is the only information that we has been provided to us. So we need to calculate the value of GM. So how to calculate the value of GM? GM is equals to IC over VT. So IC is given 2.37. So let's use the value that is given to us. And VT is always constant to be 26 milli. Alright. So in this case, if you divide this together, you will get 91.15 milli. Okay, 91.15 milli. Alright, so from here we know what is the value of GM already. So beta is equals to Beta is given 120, right? So 120 divided with 91.15 milli. So we will get our GM is equal, R pi is equals to 1.32 kilo ohm. So here they are, 1.32 kilo ohm. So your input impedance, you will get 647 ohm. All right. Okay. So and then how about our output impedance? Okay. So now let's look at the output impedance. So the output impedance, so this is your output impedance, right? So for us to calculate the output impedance, so Z out, okay, we need to consider what at the output? We have RC and we have R naught. Okay, we have RC, so RC is given 4.3 kilo. And how about the R naught? R naught is not given, so in this case we need to calculate the value of R naught. So in this case, so Z out is impedance at the output, we're going to be RC, which is going to be parallel with R naught. So how to calculate your R naught? R naught will be VA over IC. So VA, what is our VA? Given 200 and IC is 2.37 milli. So if we divide this together, we will get 83.39 kilo ohm. Alright, so in this case, we can find our Z out. So Z out we're gonna be 4.3K parallel with 83.39 kilo. So you will get how much? We will get 4.09 kilo. Alright, okay. So this is what the answer. Alright, we're gonna have this. Right, next is we need to calculate the value of, okay, alright, we need to calculate the value of AVOC. Okay, so we know AVOC is actually what? Okay, AVOC is actually V out over V in. Alright, okay, V out over V in if it is without RL. Okay, if it is without RL, yeah? V out over V in. So in this case, what is our V out? Okay, so this is without RL. Okay, alright, but in this case we have RL, right? Okay, so now let's just use the without RLs first. Okay, so if it is without RL, so what is our V out? Okay, V out will gonna be, okay, our V out, where is our V out? So here is our V out. Okay, here is our V out, right? I need to use my laser. Okay, so here is our V out. Okay, here is our V out. Okay, let's don't consider the RL first. So we have our V out. To find the V out is we're going to be equals to value of current I, okay, and then R not parallel with RC. Then we will get V out, right? And what is our V in? Where is our V in? This is our V in. Okay, V in, V in. Okay, so I over R naught multiply with RC. Okay, I, which is the value of current here, Okay, current here. Okay, parallel with the resistor R naught and RC. So in this case, if you can look here, so the value of current, your current will be flow for this way. So it will gonna be negative GM V pi. Okay, negative GM V pi, and then R naught parallel with RC, right? Okay, then what is our V in? V in here, V in is parallel with V pi. Okay, V in will equals to V pi because of why? Because it is parallel. So we know parallel, our voltage will be equal. So our V in will equals to V pi. So in this case, we can simplify this to become negative GM R naught over RC. Okay, so what is the value of negative GM? GM is the one that we have calculated earlier, right? GM is equals to IC over VT. Alright, so IC over VT is, so it's going to be 2.37 milli over 26 milli. So you will get the one as we have calculated earlier, 91.15 milli. So we can put inside here 91.15 milli. R not parallel with RC is the one that we are not parallel with RC is the one that we have calculated with the Z out, right? Which is equals to 4.09 kilo. Okay, so we will get this is negative 373. Okay, 373. But this is if it is without RL, if there is no RL. But now we have RL, so we have to consider RL. We have to consider, in this case, we have to consider RL. This is without RL. So the right AVOC with RL, yeah. Okay, so now this is with RL. So with RL, which part we're going to be different? This part we're going to be different, right? We have to include R0, RC, and RL, and all of them is parallel, right? Okay, so it will going to be negative GM V pi R0, RC, RL over V pi. Okay, alright. So we will get negative GM, so V pi can be cancelled out, and then Z out parallel with RL, right? So it's gonna be negative GM equals to Z out is 4.3 kilo, RL is equals to the value of RL is given as 10 kilo. Okay, 10 kilo ohm. Alright, so in this case we will get the value of our AV with with RL. With RL is equals to negative 265. So this is your final answer. Okay, so this is the correct answer. So the first answer here, this is without RL, right? But we want to calculate with RL. So if with RL, then you have to include the value with RL. Okay. Next, the question asks about the AVS. All right. The question asks about the AVS, or the question asks about the AV. Okay. Oh, alright. Okay. There is a question. There is a the one, the AVOC. Okay, AVOC usually it is without RL. Okay, it's easier for you to understand. AVOC usually we will not consider the RL. Okay, remember AVOC is the one that is without RL. However, if the question asks about AV, it's better to write AV. Okay. It's better to write AV. It's easier. Okay. If the questions ask about AV, alright, AV. So AV is the one, the value of voltage gain. Voltage gain with RL. AVOC, voltage gain, and voltage gain without RL. Okay, please remember that. AVOC without RL, and AV is with RL. Okay, so it's easier, alright, if you just start from the beginning. Okay, but in this example solution, I'm using the AVOC that I have calculated earlier into this and into the equation, and we just include the RL. Okay, but actually if you don't start, okay, the difference between my work solution, okay, and the example solution is, my work solution, the AVOC, I'm use the same method how to find the AVOC without RL, and how to find the voltage gain with RL with the same methods, which is always V out over V in. Okay, but the only difference is for the AVOC, the V out is before the RL, which is I only consider the resistance R0 and resistance RC. But for the AV, I consider the V out. Okay, I consider the V out resistance to be R0, RC, and RL. Okay, but the process is the same process. Okay, alright. And then once you got the AVOC and once you got the AV, now the last question asks about the AVS. So what is AVS? Okay, what is AVS? So AVS will be the gain, okay, the gain of the voltage source, meaning that we need to find the gain, which is V out. We know, yeah, gain is always output divided with the input, but what is the input now? Your V out. Okay, this is the V out. Where is the V out that we want to refer? This is the V out. So this is our output. But what is our input? The input now is the VS. Okay, it is not Vin anymore. It is Vn. The AVOC and the AV earlier, our input we only consider up until Vin only. But for the AVS, our input will become the voltage source. So therefore, we need to divide with the VS. Alright? Okay, so now, how to find this V out over Vs? Okay, so we know to find V out over Vs, it is actually V out, okay, V out over V in multiply with V in over Vs. Okay, if we use this formula, do we get this? Yes or no? Yes, right? Because why? Let's use different color. Because this V in and this V in can be cancelled out each other, right? How? Okay. So that's why we are using this. Okay, why we are using this? Because we have this value V out over V in. We have this value. What is this value? This is actually the value from the AV here. Okay, the value from the AV that we have calculated earlier, right? And the V in over Vs is the one that we can calculate it later. Okay, so one part has been solved. So that is why we are using this formula. That is why we are using this formula, because one part has been calculated. Okay, what is this? It is the V out over V in, which we have calculated AV. So we can use V out over V in to become the value of AV, which is negative 265. So the only left behind that we need to calculate is the V in over Vs. So V in over Vs. Okay, now let's calculate that V in over Vs. Okay, so for V in over Vs, alright, V in over Vs, using the different color pen. Okay, so let's draw the circuit. So the circuit will gonna be, so this is your Vs, this is our Rs, this is our Rs, and then what else do we have? We have V in, Z in. We have Z in, right? We have V in. So now let's consider this. We have Z in, or you just write as I. Z in, and we have what? across here we have V in. Okay, so this is our circuit. Okay, so now based on this circuit, can we find what is the value of V in? Okay, we need to find the value of V in. Okay, we need to find the value of V in. Okay, V in, so this is Vs, right? Okay, this is Vs, right? V in is actually equals to, if we look here, we can use a voltage divider, which is Z in over Z in plus Rs multiply with Vs. Am I right? This is actually a voltage divider. We can use a voltage V Thevenin that we have used before, which is to find the voltage across here, because this is another one. Yeah? We want to find the voltage across here. We have two resistor. Okay, so we can use the voltage divider part, which is V in is equals to Z in, the one that we have calculated, over Z in plus Rs multiply with Vs. Alright, so in this case, we want V in over Vs, right? We want, our objective is to have V in over Vs. So what we can do is, we can rearrange this equation. You don't have to solve. We can rearrange this equation. V in over Vs. If we bring this Vs to this side, we will get V in over Vs, which is equals to Z in over Z in plus Rs. Right? So from here, do we have the value of Z in? Yes, we have calculated earlier. Do we have the value of Rs? Yes, as well. We have calculated earlier. Right? So we can get the value of V in over Vs. So in this case, we can get this V out over Vs to become, multiply with V in over Vs. So the AV just now, we got the value is negative 265. So don't left the negative, yeah? We need to have the negative. Multiply with the value of V in over Vs, Z impedance earlier. We have calculated the value of Z impedance to become 647 ohm, right? So 647 ohm, 647 over 647 plus, what is the value of Rs? Rs is given as 600. Then we will get the value to become negative 137.5. So this is the value that we got. Okay, alright. Okay, so this is how to solve this equation, this solution, this example. So you can see it is actually a step-by-step process. Alright. Okay, so now let's go to the next example. Okay, so for the next example, example 1, yeah, there is an additional questions where in these questions they ask us to determine the values of current gain. Okay, so this is the current gain, current source gain, okay, current source gain, and power gain. Okay, so this is the power, so meaning that it's gonna be power at the output over power of the input, and AIS will gonna be, okay, I for the output, current at the output over current at the source. Okay, where is the current source? Here is your current source. This is the IS. Where is the I out? Here is your I out. Okay, and AI here means that I at the output over I at the input. Okay, I at the input. Alright, so now let's look how to do the current. Okay, current gain. So AI. Okay. Okay. So AI is I at the output divided with I at the input, right? So how to find I at the output? we need to find the value of I at the output first. Okay, so I at the output. Okay, so now let's draw the KVL. We can use this KVL. Alright, so we have AVOC that we have calculated before. Okay, AVOC V in, and then we have Z output, and then we have RL, okay, alright, so this is the I output. Okay, I for the output, right? Okay, in this case, why we are using the AVOC? Okay, AVOC now will become our new current. Okay, AVOC now will become our new current because of why? If you look at this structure, okay, V in, okay, we have V in multiply with the current, okay, AVOC, so we will get the value of the total of the voltage, okay, the total of the voltage. So AVOC will be the will become AVOC V in will gonna be our total. Okay, if we write it as AVOC V in, it will become our total source for this at the output area. Okay, at the output area. Alright, we are no longer using GMV pi and R naught because we have calculated the relations of GMV pi R naught with the input. Okay, we have calculated the gain earlier when we want to calculate the AVOC, which the AVOC is actually the output source divided with the input source, right? The gain at the output and the gain in the input. So the relation between the gain at the output and the gain at the input, if we multiply with the V in, it will become our total source for the whole structure. Okay, so this is the output impedance and this is the RL. So we can simplify the circuit to become like this. Okay, so at this it will no longer have the input lah, we only have the output because the relation between the output and input we have simplified it in the AVOC. Alright, okay, so now let's perform the KVL for this structure. So this structure we're gonna be, the KVL we're gonna be, okay, the KVL we're gonna be, so this is positive and negative. Alright, so it goes from negative, so negative AVOC V in, alright, plus I out, okay, I out multiply with the total impedance, right? Z total resistor Z out plus RL, we will get this is equals to 0. Okay, we will get this is equals to 0, and since that we want to find the value of I out, so we will get I out is equals to what? I out will equals to AVOC V in over Z out plus RL. So this is the value of I out. Okay, so we can include inside here I out is equals to AVOC V in over Z out plus RL. Okay, now how about V in? What is the value of I in? Sorry, what is the value of I in? So for I in, okay, I in is equals to V in is equals to I in multiply with Z in, right? V at the input, so this is our input, V in multiply with I in, right? So this is the I in is at this particular part. Okay, I in multiply with the Z in, we will get V in. So I in, yeah. I think I wrongly write here, IN, it's supposed to be I in. Okay, so I in, if we arrange this equation, it will become V in over Z in, or Z impedance, Z input, Zi. Alright, so we can replace inside here. This is over V in over Z in. So in this case, we can cancel out the V in. So it will become what? It will become AVOC Z in over Z out plus RL, right? So we have all this value from our earlier calculation. AVOC is equals to negative 373, Z in is 647 ohm, Z out is equals to 4.09 kilo, plus RL is equals to 10K. So we will get the value of current gain to become negative 17.13. So this is the answer. Okay, so this is the answer. Okay, 17.13. So how about AIS? Gain between the output and the source. So gain at the output and the source, let's use the same formula. AIS is equals to I out over IS. And how to find I out? I out is equals to I in, right? And IS is equals to I in. I wrongly write. I in over IS, right? So I out over I in we have calculated earlier, which is negative 17.13, and left behind is only I in, and sorry, it's going to be very difficult to distinguish. Left behind is only I in over IS. So this is the one that we need to calculate. Okay, so now let's look into this, how to calculate I in over IS. Okay, in order to calculate this, we need to use the current divider rule. Now this is different, yeah, not voltage divider, but we are using current divider rule. So for current divider rule, we have to convert this Vs into current. So it will become, our current now will become as such, okay, because this is positive, this is negative. Alright, and then we're gonna have Rs. Okay, this is our Rs, and this will become our Z in plus negative V in. Okay, so for current divider rule, it will gonna be opposite with the voltage divider rule. So in this case, you can see your Rs is actually in series. So in voltage, right? So in current, it will become parallel. All right. So where is your I in? I in will gonna be here. Here is your I in, right? And this is gonna be your IS. Okay. Alright, so for you to find the current divider rule, how to find the I in? Okay, so I in, okay, so here you can use same as voltage divider, Rs over Rs plus Z in, okay, multiply with IS. So here is your IS, yeah, okay, IS. So to find I in over IS, the relation I in over IS, you just rearrange this equation, you will get Rs over Rs plus Z in. So we have this value, okay, so multiply with the Rs over Rs plus Z in, so you will get negative 17 point minus, So you will get negative 17.13 multiply with the RS, which is the value of 600 over 600 plus input impedance to be, what is the input impedance earlier? 647. Okay, input impedance 647. So you will get the value to become negative 8.24. Okay, gain doesn't have any symbols, so you will get as such, right? So this is for the current divider rule. Next, we need to find the power. Okay, so for the power, okay, AP power, so it's gonna be power at the output over power, oh lama, I couldn't write down here, yeah, it has been the limits. Okay, where to write, okay, let's use space here. Power at the output over power at the input. Okay, so power at the output, power at the input, so it will gonna be AV multiply AV, gain of our voltage, okay, voltage gain multiply with the current gain. Because of why? We can simplify to be like, become like this, because for the voltage we have considered output over input. For the current as well, we have considered output over input. Alright, output and input, output and input. So to find power, we know power is voltage multiply with the current, right? Voltage multiply with the current. So we can just use the voltage gain multiply with the current gain earlier that we have calculated. So you will get negative 265 multiply with negative 8 point, not 8. It is not 8, right? AI is equals to, okay, 17.13. So you will get 4.54 kilo. Okay, alright, clear, yeah? Okay, so that is the answer. Okay, so now let's look at the exercise 1. Okay, now let's look at the exercise 1 together. Alright, so for the exercise 1, the questions ask about the draw a small signal AC equivalent circuit which we need to assume VA is equals to infinity. So when your VA is equals infinity, do we have R naught? No, right? So there gonna be no R naught for you to consider. Okay, because your VA is infinity. We have discussed this on the previous class, so please go back to your previous class lesson. Okay, let's say if you are blur. Okay, so now we need to draw a small signal AC equivalent circuit. So first of all, we need to draw the AC equivalent circuit. So what we have to do, we need to replace this VCC into ground. Okay, all the VCC will become ground. Next, what we have to consider, first VCC will become ground. Second, capacitor will become short circuit. So here will become short circuit. Here will become short circuit. So therefore no RE. Here will become short circuit. Okay. Next, what else? Then we have to consider the value of R pi. Okay, the value of R pi, which is this part will become our R pi model. Okay, R pi model. Okay, hybrid pi model. Sorry, hybrid pi model. Okay, hybrid pi model. Okay, so let's draw the circuit. Okay, so the circuit we're gonna be how? Alright, so we're gonna have VS here. This is our VS. So we're gonna still have our VS. So this will become our VS. Next, we have our RS. So this will be our RS. RS, yeah, not RC. Okay, RS. Next, it will meet to this junction. For this junction, we have R1 and R2 in parallel. So we can draw R1 parallel with R2. Okay, we can draw like that. But between R1, before R1 and R2, we have what? We have Vn. So therefore, at this part, we're going to have Vin. Okay, and what else do we have? We have Zin, which is this particular part, we have Zin. Right? Okay. So this can be connected. Next, what we have, it will meet to this base. So it will goes to this base. So this will gonna become our base. So usually at the base, we need to apply the hybrid pi model. So the hybrid pi model, we're gonna have here, we're gonna have R pi, right? So across R pi, we're gonna have positive, negative, V pi. Okay. So from here, we can connect here. So it will goes to our emitter. So this is our emitter. How about at the emitter? Do we have any resistor? No. Straight away, it will goes to ground. So this is ground. Next, what else? We will go to the collector junction. So at the collector junction, usually we're going to have what? We're going to have the GMV pi. Okay, you can draw triangle, you can draw like a diamond, or you can just draw a circle like this. Both are correct. We're gonna have GMV pi. Okay, so this is our GMV pi. Do we have R0? No, we don't have R0 because our VA is equals to infinity. Okay, so now we can, so this is our C, okay, collector junction. So at the collector junction, what we have here, we have two resistor, RC2 and RC1. So both of this is parallel. So we're gonna have RC1 parallel with RC2. Okay, and it is connected to ground because it is going to VCC. So this is connected to ground. And then what else do we have here? We have the RL, load resistor. So we're gonna have RL. So this is gonna be your RL. Okay, RL. Okay, load resistor. So we're gonna have positive, negative, V out. And then what else do we have? Before the load resistor, we have the output impedance. So this will gonna be your output impedance. Okay, so this is your our small signal equivalent AC equivalent circuit. So this is the answer. Okay, all right. Okay, now let's look for the next discussion, which is regarding on the common emitter unbypassed RE. So in these questions, okay, in these questions, what we're gonna discuss is we will have the unbypassed RE, which is, if you look here, there is no resistor. Okay, there's no capacitor located at the emitter side, meaning that there gonna be no short circuit. So if there is no short circuit, you have to consider your resistors at the emitter. Okay, so what happened here is we have removed the bypass capacitor. So as a result, it has increased the amplifier input impedance and reduce in its voltage gain and increase in its output impedance looking into the collector. So meaning that when there's no capacitor, so you have to include the resistor of the emitter in the circuit. So how your circuit will gonna looks like? Okay, so your circuit will gonna looks as such. So you can see, usually your emitter will connected to ground. So now what you have to include is you need to have RE for your emitter side. You need to include the resistor before it is going to ground. Okay, before it is going to ground, you have to include your resistor. All right, now let's look how we can have all of this what we call here equation. All right. Okay, now let's discuss how we want to get this the equation earlier. Alright, so let's look at the structure of your hybrid pi model now. Equivalent AC small signal circuit. Alright, so you can see here we have R pi, we have V pi, and this is your resistor at the base. Okay, your base resistor. Okay, so this is your impedance at your base. Okay, you're gonna have two impedance now. We have input impedance and we have impedance at the base, where impedance at the base is right before the base, yeah, right before it's going into the base, and it is after the resistor of the base. Okay, and then we're gonna have R pi, and then we're gonna have RE here. Okay, resistor at the emitter side. And what else do we have here? We have GMV pi, and then we have RC. Okay, so if you look at this structure, our R pi here, okay, it is actually not in series. Yeah, our R pi here, it is not in series with our RE. Because of why? If you look at the junction here, the current now is splitted. One is going to the emitter, and another current coming from the collector is going to this emitter. So it is actually R pi and RE here is not in series. So in this case, we need to introduce something. Okay, we will need to introduce something which we call it as our VT. This is a little bit longer calculation here. We have VT. Alright, we have a new voltage here, which is the voltage here, total voltage here is V pi plus VE. What is VE? This is our VE. Okay, this is our VE. So how to find our VE? VE is equals to what? IE. What is our IE? IE is GMV pi. Because of why? Why we can use this? Because we know for a good resistor, collector current IC almost same with IE in DC. In DC analysis, right? In DC analysis, we can say for a good amplifier, usually IC will gonna be equals or similar with the value of IE. Alright, so same goes with the AC analysis. Alright, for a good amplifier, usually IE will be equals to GMV pi, which is this value. Alright, which is that value. So in this case, okay, we can write, how about V pi? What is the value of this V pi? V pi will equals to IB, because this is the value of IB. This is the current IB. IB multiply with this value of R pi. So we can put inside here IB R pi plus VE is equals to what? IE RE. Okay, this is your R pi. Okay, so from here we know IE. Okay, we know, yeah. Alright, I just want to show to you how we got the formula that I had shown to you earlier. Okay, so we know IE is equals to beta plus 1 IB as well. Did you still remember? This is what we have discussed in DC analysis. IE is almost equal beta plus 1 IB. So in this case, we can replace this into here. We can substitute. So therefore, your VT, it will become, okay, our VT, it will become IB R pi, okay, IB R pi plus beta plus 1 IB RE. Okay, so from here, okay, where is your VT actually? Where is this VT? VT is the total voltage here. This voltage. Okay. This is your VT. So you can see VT actually is this V pi plus with this VE. Alright. So from here, okay, we can know as well VT. Okay, so this is the first equation of VT. Another equation of VT. Okay, this is the first equation of VT. Another equation of VT is this VT. I need to have my laser come down. Okay, so this VT as well. It is what? It is parallel. It is also voltage across this, which is ZB, the impedance here. Okay, ZB multiply with what? Multiply with this IB, which is, if you can look here, this ZB is the impedance for this side. Okay, so another equation for VT which we can write is ZB IB. Okay, ZB IB. And from here, can we find the value of ZB? This value of ZB? Yes, right? So ZB is equals to what? VT over IB. Alright? Okay, clear, yeah? So next, what is our VT? This is our VT that we have calculated earlier. Okay, this is, we can use, so what is this VT? I need to use a different color of eraser. Okay. Alright, terpadam pula pencil. Okay, so the VT is the one that we have calculated earlier. Okay, this VT, we can substitute with this value. So therefore, we can rewrite our equation to be, because we cannot use VT, because VT, we don't have the value of VT. So ZB, to find the value of ZB, it will be IB R pi plus beta plus 1 IB RE over IB. So now, can we simplify this equation? Yes, right? We can cancel all the IB. So you don't have to find the value of IB. IB, IB, and this IB can be factorized and can be cancelled out each other. And we can get our final equation for the ZB is to be R pi plus beta plus 1 RE. Okay, that is the value of ZB, or impedance at the base. Alright, R pi plus beta plus 1 RE. Okay, so that is the value of ZB here. How about the input impedance? Your input impedance will be RB parallel with what? ZB, right? RB, our input impedance will gonna be RB parallels with ZB, which is, the ZB is this value, which is RB parallel with R pi plus beta plus 1 RE. Okay, you can include inside here. Okay, this is actually this value. Alright, so from here, actually, you can solve what is the value of ZB. Okay, so where is your ZB? Here is your ZB, and we also have find the value of input impedance. So this is the value of your input impedance. Okay, alright, so now let's look for the output impedance. Okay, our output impedance, in this case, we have our output impedance. So Z out is equals to RC. I think this is very straightforward, because we only have RC here. We don't have RL. If there is RL, then you need to consider the RL lah. But usually output impedance, it does not include the RL because it is usually before the RL. Okay, so RL usually comes after, will be after the after the output impedance. Yeah, so usually RL, we're gonna locate it somewhere behind here, so you don't have to consider the RL. So but if the RL is before or the output impedance is after the RL, then you have to consider the RL lah. But usually Z out or output impedance is only RC only. Okay. Okay, next, what else that we need to consider is the voltage gain. Yeah, the voltage gain. Okay, so this is another one, and this is another one, the importance one, right? Okay. Okay, so now we need to look at the voltage gain. So we know to calculate this voltage gain, it will gonna be AVOC. AVOC. So AVOC is what? Voltage at the output over voltage at the input. Okay, so voltage at the output, okay, AVOC, this is without RL. Okay, because there's no RL, right? So without RL, so voltage at the output. So now let's look at the voltage. It's gonna be the voltage across RC. This is our voltage at the output, right? So it will gonna be same as before, negative GM V pi RC, okay, over Vn, right? So Vn, what is our Vn? Okay, so this is our Vn, here is your Vn, and if you can look here, our Vn is equals to Vn is equals to what? It will gonna be Vt. I need to have my laser. So this is our Vn. Vn is equals to Vt. Okay, Vn is equals to Vt. Pencil is equals to our Vt. And what is our Vt? Vt is V pi plus Ve, right? V pi plus Ve. So V pi plus Ve we have calculated to become IB R pi plus beta plus 1 IB RE, right? So we can include inside here. So this will gonna be IB R. It's better to write properly. It's better for me to write properly. So it's gonna be IB R pi plus beta plus 1 IB RL. Okay? RE. Sorry, there's no RL. RE, yeah? Okay, RE. Alright? And then from here, okay, what we can simplify, okay, we can simplify V pi, okay, because we know what is the value of V pi. Alright, we know what is the value of V pi, right? V pi is equals to what? V pi is equals to IB R pi, right? So we can simplify this to become negative GM IB R pi RC over IB R pi plus beta plus 1 IB RE. Okay, so we can, what we can do now here is we can cancel and simplify the IB, so it will become negative GM R pi RC over R pi plus beta plus 1 RE. Okay, alright, so you will get, this will be your value of AVOC. Okay, so you can leave up until here, because usually we have the value of GM, we have the value of R pi, we have the value of RC, we have the value of RE, and we have the value of beta. But let's say if you want to make it simplified, we can simplify this. Okay, you can simplify this, which, okay, because we know the value of R pi, I need to use this color pen. Okay, we can simplify, you can simplify, okay, because we know the value of R pi is equals to beta over GM. Okay, so you can cancel the value of R pi, so your AVOC, okay, to become the value of negative GM. Okay, your R pi will become beta over GM RC over, okay, beta over GM plus beta plus 1 RE. And from here, you can simplify this equation of mathematics to become negative GM RC over 1 plus GM RE. Okay, right, so this is actually the same, just a simplified version by replacing R pi equals to beta over GM. Okay, next we need to find the current gain. Okay, so how to find the current gain? Right, how to find the value of the current gain? Where to write? I write it here, yeah. Okay, but before we go to current gain, let's say if the value of your GMRE, okay, this value of GMRE is too large. Let's say GMRE is larger than 1. It's larger than 1. It's very, very large. So your AVOC in this case, yeah, in this case, your AVOC will become, okay, negative RC over RE. Okay, and this is only applicable if your GMRE, you multiply GM with your RE, is very large, more than 1, then you can simplify your AVOC to become negative RC over RE. Okay, so now let's go to for the current gain. Okay, so for the current gain, okay, same as what we have discussed in previous circuit configuration, we can redraw, okay, the structure. For the current gain, it's gonna be AI over I out over I in, right? I in. So to find this I out over I in, we need to redraw the structure. So this will become your AVOC V in, okay, and then we're gonna have output Z out. This is your Z out, and then we're gonna have RL. Let's say you're gonna have RL, and then we're gonna have, okay, so like this. So the KVL we're gonna be like this. Okay, all right, so your equation we're gonna be same as before. Okay, what we have discussed before, we're gonna be negative AVOC, okay, your KVL, yeah, okay, negative AVOC V in plus I out. So this is at the output, yeah, okay, gonna be I out Z output plus RL equals to 0. So if you want to find the I out, it will gonna be AVOC V in over Z out plus RL. Okay, so we can include inside here, so this will gonna be AVOC V in over Z out plus RL, but this is not finished yet. We need to find the value of I in. So what is our I in? Okay, I in is equals to, of course, okay, it's gonna be I in, we're gonna be V in. Okay, what is the value of V in here? All right, because we don't know, I need to circle so that you don't know. So inside here, if you look here, there is a V in. So what is the V in? V in is equals to I in Z in, right? I in Z in. So in this case, we want to find, sorry, so let's erase this first because it is not complete yet. Okay, so in this case, we want to find the relation between I out over I in. So it's gonna be, you just rearrange this equation, I out, I in, this is the I in. Okay, so you will get AVOC Z in over Z out plus RL. Okay, and then you replace inside here lah, AVOC Z in over Z out plus RL. So this is going to be the equations of current gain. Okay, next, what is another equation? Let's say, how about the what else? IS, AIS. Okay, sometimes they will ask about the AIS. I think I need to use a different color pen as well. Okay, let's say if you want to find AIS, which is I out over I source. IS, yeah, source. Oh, it's cancelled. Oh my god. But it is recorded earlier. I think it's okay, yeah. It has been cancelled. I want to, oh mashallah. Okay. So we want to find AIS, right? We want to find AIS. So it's gonna be I out over IS, which is 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 for the source, yeah. So it's gonna be same as before, I out over I in multiply with I in over IS. So it will gonna be, so I out over I in, so this is the one that we have calculated, which is this is actually the AI, right? So the answer for this part is gonna be AVOC Z in over Z out plus RL. So left behind is only this particular part. So for this particular part, same as what we have discussed earlier, you need to use the current divider rule. Okay, use the current divider rule, which your circuit will be, okay, your circuit will gonna be okay, this will gonna be IS. Okay, so this will gonna be your RS. Alright, so this will gonna be your Z in. Okay, this is gonna be your Z in, and this is gonna be V in. Okay, we only consider up until here. So this is your I in, and this is your IS. Alright, so for here, for this part, okay, you're gonna be your I in will gonna be, I in will be, okay, RS over RS plus Z in multiply with the value of IS. So we want to find the relation of I in with our IS. So we can rearrange the equation. I in over IS is equals to RS over RS plus Z in. So we can put inside here RS plus Z in. So you will get, this is your relation of AIS. Okay, all right, so this is it. Okay, this is it, the oh mashallah, this is the, okay, this is what we have discussed just now. All right, I've shown you how did we get all of this. All right, all of this equation just now. Okay, AI, okay, I with the output. Okay, I with the output, we're gonna be the negative AVOC, right? But I think I forgot about the negative here. So it is actually origin from the AVOC. Since that our AVOC is negative, so you just have to include the negative. Okay, I think I left the negative part here previously. Okay, so you just add the negative part. Okay, it's supposed to have the negative part lah, because our AVOC has the negative part, right? Okay, and then next, for the Z test and the I test, right? Okay, for this part, okay, I think I will skip this part because this part will not be included. All right, this will not be included in your in your um, in your test and in your final. So we can just skip for this part, right? And let's go into this example number 2. Okay, so for this example number 2, I think I will explain to you guys during the class, okay, on Friday class. So I hope you guys can look this, okay, and I think we finish about this. After this, we will focus on the board plot. Right, thank you so much and see you on Friday class.